that Rain is dealing with some sort of fire on her end, so she's going to try to join us later, or join me later, as I'm probably the only one here. Last week we were trying to put together a weather station, and we built a bunch of, we soldered a bunch of headers on stuff and talked about stuff. I have gone ahead and finally assembled the weather station. So weather vane, anemometer, rain gauge, and it's got 2 cords coming out of it with RJ45 jacks so that we can hook that up. And what I started doing was building a circuit to read all that, because SparkFun was out of their carrier boards for that. And I will show you a little bit of what happened there. This is my desk, and you can see there's my coffee for today, and I was building a little circuit here, and it turns out that without that carrier board, it was requiring a bunch of I had to put some small capacitors in there and a bunch of other sort of passives and stuff. And remember, we put together these little RJ45 boards. And so I was working on that, and it was going okay, but it was going to be a complete mess to put into a box. So I went back to SparkFun, and I noticed, I don't know why I didn't notice it the first time, but I noticed this really cool board. And what this board is, you can see it's got the RJ45s for the weather station. It's also got a BME 280 on it, which is a temperature, humidity, and pressure sensor. And it's got the lightning detector on it. So it's got all that on it. And then this little tiny drop-in board here is an ESP32. So it gives me everything that this did, and then more, without having to hang a bunch of sensors off of it like I was going to. So that turns out to be just the ticket. And remember, I was going to add a CO2 sensor, so this morning, actually, already, I have gone ahead and wired up this CO2 sensor, and you can see that, let's see, if I turn it this way, you can see that the light is flashing, and it's actually collecting data. So let's go over to where I was writing code, and I'm hoping that's big enough, but I can make it bigger. Wow, something's really sucking the life out of this. Sure, it's got nothing to do with the streaming. So this morning I added in the SparkFun SCD30, which is that CO2 sensor, and I'm using the SparkFun ESP32 micromod board, and I believe let's restart the serial port. Oh, look at that. We got a disturber. That is a lightning strike. We are having a thunderstorm this morning, so the lightning strike did actually work. So I will now reset the board. And there it is. And you can see that I'm getting temperature, humidity, pressure, altitude. The UVA-B index is going to be 0 because I'm indoors and it's cloudy anyway. Soil moisture sensor is not attached, so that's a completely made up reading. The wind direction, as you can see, I'm not actually plugged in, so it's just going to return a -1. But we are getting CO2 at 871 parts per million, and this little guy also has a temperature and humidity on it. So this one's saying 41.2 and that's saying 42, so pretty close, right? That's not bad. And it's sort of going every, oh, we had another, we're getting lightning strikes. This is getting lightning, any lightning indication from several kilometers, I think it's 20 kilometers. So since we are in the midst of a thunderstorm, we're most likely going to be getting a bunch of those. And in fact, I guess I can go ahead and, I should have put this out last night. I could have gotten rain data. But here we have the wind and wind direction data. And so we'll plug that into the wind jack. And now, if we're lucky, look at that. We have a wind direction of 293 degrees, 315 degrees, 270 degrees. So the wind vein is over here, and it's moving around a little bit. Oh, and a wind click, right? So we're now getting our wind direction, and if we spin that, we should see wind clicks. What I have to do next is most likely write some code to convert those wind clicks into a wind speed. We're at 113 degrees. And what I've noticed is that this library does give some errors on the wind direction as it goes. It will occasionally go just back to -1 degree, right? And that's clearly not correct as it's moving. So we'll have to look at what's going on there. So the two other things that I need to do to make this weather station board complete is, because the two other things that I wanted to measure were soil moisture. That's going to be fairly easy. I'm just going to have to attach one, and this board has a specific attachment for soil moisture, and the sample code that I grabbed from SparkFun, as you can see, is already trying to read the soil moisture, so all I really have to do is get one of my soil moisture sensors and plug it in there. But the other thing I wanted to do with this board is, with this weather station, is I wanted to collect particulate matter, so I can look at pollen counts and pollution and things like that. And I have this guy, which is actually from Adafruit. I could have gotten it from SparkFun, but I had one lying around from Adafruit, and it is it's called a PMSA003i, and it's a PM 2.5 detector, so it will detect all sorts of particulate matter. And I've already got the headers on it for the pinouts. And if I go and look, I believe I have a tab open for this at some point. You can hear the dog in the background. He's clearly upset that nobody else is awake yet. Here it is. So here's the wiring diagram. This is I2C. Cool thing, the CO2 sensor is also I2C. And so it's already plugged into the I2C pins, but what's really nice about I2C is I can plug multiple things in, and they have different addresses, and so I can use the same two wires to address all of these. The soldering on this, I didn't realize that I was going to be putting everything into the I2C, so it could be a little bit interesting on the soldering. But the other thing we can do is we can go to SparkFun, that's the forum. So this is the ESP32 micro mod board that I just got. And so it's this little tiny board. It has the ESP32, and there you can see the little antenna on it. And so that's what I That's the board that I got. This is a different micro mod carrier board. But somewhere here I have the carrier board. Or do I? Right, here's the carrier board that I have. So I put my ESP32 board in it, and here you can see how they've hooked up their weather station. I'll do the same thing. It's just a plug and play. Here's a weather soil moisture sensor that they've plugged in, and I can go ahead and do that today. What I really want to see is on the hardware overview. Aha. Here's what I'm looking for. I want to see about the I2C pins. It looks like I only have the two I2C pins. Yeah. Now, one of the nice things about this little Adafruit board is if I don't want to do it over I2C, I can actually do it on it's got, does it? It should have. The old one did. Maybe it doesn't anymore. Nope. They used to have a UART on there, and you could just read it straight out of the UART, but I guess they don't anymore. So I'm going to have to go and solder into those tiny little pins again. That's going to be fun this morning. So let's actually start with the moisture sensor, since that's going to be easy peasy. So here's a moisture sensor. Really simple thing. You put it in the ground. It measures the resistance between these two electrodes in the ground, and that tells you how much moisture is in the ground. It's got already a screw terminal header on it. It just takes 3 wires. That's real, and it's not even going to take any soldering on my part. Outstanding. Over here in my box of tricks, I have a bunch of these things. These are really cool. I bought a huge number of them because I like them so much. It's a barrel connector. It's a weatherproof barrel connector. I have a bunch of different ones with a bunch of different leads on it, and this is a 3-lead version. Black, red, and yellow. 3 leads. So I can put this right on. What I need to do is get the other end of it. So this is the screw end, and here is the other end. And I'm going to take this end right here. Remember I told you that I was famous last time. I told you I was famous for live hooking things up. I'm actually going to be smart today. So we're going to unplug that so it's not live when I'm putting things in it. This board is actually very well labeled. It says power, ground, and signal. So power is red. Open all these little connectors up. Power is red, and with Clamp that down on the red, nice and tight. Ground is black, so that goes in there. And again, we'll lock that down nice and tight. And last one, we'll go with signal on yellow. So that goes in there. Lock that down nice and tight. Great. Now we have this nice little barrel connector here. And all we need to do is take our moisture sensor. Looks like somebody soldered these two together when they didn't let the solder. There we go. So this is a screw terminal connector. Somewhere, here it is. Handy screwdriver. We'll loosen the connectors on here. Basically works the same way as those lever connectors, except with screws. So, this is signal, ground, and power. Power is, for those of you who don't do a whole lot of hardware, sometimes it's not labeled power, sometimes it's labeled VCC, which is the voltage from the voltage regulator. So I'll screw that down nice and tight. And next we go with ground. Goes right in the middle one. And we'll screw that down nice and tight. Make a good solid connection. And then this one is the signal. Goes into its little holder.
Hey!
Hey there! It's nice to see you, Rain.
Hello. Let me pull up the screen.
So I am sort of going through the last of the hardware on this thing.
I can't actually hear you yet because the Zoom is muted. So let me pull up the screen. Hey!
Hey there. It's so good to see you. Thanks for coming. Huh?
There we go.
You good? Can you hear me?
Yes.
Yeah. So I was going over what we did, a little bit of what we did last week. Remember we were trying to build the sensor on one of these boards? And that was, it turns out as I worked through it the rest of the week, that was getting to be way too much. I was having to add resistors and capacitors and stuff external to everything, and it was like, well, I showed everybody, I'll show you because it's just a nightmare. This is what I ended up having to build on my desk, right? Just wires and resistors and some capacitors everywhere. And I was disturbed and I couldn't get it and it was driving me crazy. So what I ended up doing was going back to SparkFun and finding this really cool board here that has everything. I just plugged my weather station into it and it works. And then...
So you don't have to build out all this stuff.
I don't have...
Nice.
Right. So all the weather station stuff works. It has a temperature, humidity, and pressure sensor. It's got the lightning sensor. It's really cool. And I went and added the CO2 sensor to it just this morning, right? And I'm just plugging in a soil moisture sensor, which is really easy to do because it's got screw terminals, and I have these
water sensor.
Yay! And I have these really handy little weatherproof barrel connectors because I went on like Alibaba or someplace and bought a bucket load of them. And it only goes in one way, so pull this back and you plug it in like that and you screw it down.
But it doesn't have an awesome...
This has a connector on it like that. So now I have a weather sensor, and if I have a soil moisture sensor, and if I plug this back in and go back to where I was writing bad code, you'll see that, hello, I might have to restart this. My machine is like going really, really slow today.
What language is this? Because I can't see it very well.
Do you need me to blow it up? I mean, like, make it bigger.
There we go. Bigger, bigger, bigger. Well, you know, you choose. Choose your own adventure.
Well, and then we can, if you want to work on your sensor, we can work on your sensor too. Please hold. Something is sucking the life out of my machine, and I want to find out what it is.
Yeah.
It's probably OBS, but no. Yeah, it's OBS on the Windows server, which is like freaking out. Okay, anyway. Is that a little easier to see now? Is that code easier to see?
No.
Yeah? Okay.
Yeah.
All right, I'm going to close down all this stuff. So this is, it's Arduino script, but it's basically C++. So let me see what I've got. So here you can see the actual output from this this board right now. And if I grab onto the soil moisture sensor, so that there's some, soil moisture sensor just jumped from 0 to 2109, 20, right? So I'm actually getting real readings off the soil moisture sensor. And
Dip it in water.
I could stick it in my coffee, I guess. But I don't have a glass of water handy. But you can see that I'm getting CO2 and temperature and humidity. This line here is all coming off the CO2 sensor. And so the temperature says 22.9 and the humidity is 43.07, and this one's coming in at 43, which is the other humidity sensor, so I'm guessing they're really close, right? And if I go over here and do this, which, sorry, I just breathed on it really hard. Holy moly, it jumped to 2,000 parts per million.
Yeah.
So that's all working, right? And basically I've got everything working here except the PM2.5 sensor. And it's an I2C device, and you'll see that I already actually, in this code, I imported the library for the Adafruit PM2.5 air quality index sensor, right? It's right here. Everything else I've gotten from SparkFun. So I've got all the other SparkFun libraries here because everything else I got from SparkFun, but this is, I just happen to have this lying around, right? Just happen to have it lying around. And I went to, here's the Adafruit page about it, and it shows me what the pinouts are and all that, right? Let's go back over what I did to get the, I'm not doing that yet. But what I did to get the CO2 sensor working, right? I imported the...
I'm listening.
Okay. When my machine is under heavy load, the scroll doesn't work very well. So I imported the SparkFun SCD30, which is the CO2 sensor. And I called it SCD30. I called it an air sensor because I'm, super good at naming things. And when I set it up, here it is. Air sensor dot begin. Ooh, tough code, right? Because the library, the air sensor library handles all that. And so if it comes back false, it means that they can't find it. So their sensor not detected, and then it hangs forever. But we connect to the I2C, the air sensor, and then if I go down to my scrolling is really.
You have to tell it what kind of error messages to send you. It doesn't have any error messages by default.
It doesn't have error messages other than no, you didn't get anything, right? So when I want to read from it, I ask it if there's data available from the CO2 sensor. If there's data available, I can go and get the CO2. I can get the temperature. I can get the humidity, and then I just print them out, right? And that's how we're getting the CO2, temperature, and humidity, right? And I could format that a little better, but I didn't. So a lot of folks do this, the serial.print and then the serial.print, line to do all this. Actually, the way I would do this is printf is a standard C call, and you can printf, if I could spell it right. What is wrong here? There. My machine is like so lagging right now. So I can do CO2, and that is an integer, and then I can print a tab, and then I can print oh, this may not work. We'll see. That tells it to print a floating point, and then I can add the then we'll put another tab. Wow, this is really slow. And then and that's another. Oops, sorry, I forgot to put the point. When you're printing floating points, if you put the 0.2 there, it'll tell it to only print 2 past the decimal point. We'll have to see if I have an updated library for this, and then we're going to do a new line at the end of that. And then the variables in order are CO2,
Python like cool.
temp C, temp underscore C, and home. And it's going to complain because I can't print these values yet because I haven't even declared them. So if I move this down to the end, wow, this is just so slow. Problems 3. I know, it is so struggling. Yeah. We're going to ignore all that. For some reason, if you're using the Arduino IDE, it will find stuff a lot easier. Using the plugin for code, it sometimes says it can't find things that it actually can. The original Arduino IDE is, how to put this delicately, absolutely awful. It is truly dreadful. And they have a new version out, and I can show you that. This is it's called Arduino IDE, and it's in either alpha, it's beta 5, and it's better. But it still has some issues. I can no longer even run the original IDE on my laptop because I have somehow screwed up the environment for it sufficiently by running Arduino development in 3 different IDEs that it's just given up. So I can't even start it. It just crashes on start. So let's see what happens if we try to build this. This is probably going to be super.
One line needs to be aligned to its serial different line.
So the nice thing about C and the bad thing about C is that, well, first of all, the nice thing is that white space is not significant.
Doesn't fit.
Right? So it can be misformatted and the compiler will still work. That's also the bad thing because you can absolutely miss things that you would ordinarily catch because you didn't properly format it.
Right. Right.
Ah. See, it told me that I left out. So white space is not significant. But a semicolon at the end of the line is absolutely significant. So it told me in this program at line 205 expected this before this. And 205 is here, but the error is actually in 203 because I didn't put the semicolon. So now let's try that again.
Yep.
And I'm just verifying it. I'm not actually downloading it this time. You can either just verify it, which is just make sure it compiles before you download it, or you can do both at once. And a lot of times I'll do both at once, but then I just get to watch the board crash because I did something stupid.
Yeah.
It's just so much fun. Nothing more fun than watching code compile. Right? It's also the greatest excuse for screwing around at work is, what are you doing? I'm waiting for a compile. Yeah.
It's pretty cool.
Yeah. Looks like you're just surfing the internet. No, I'm waiting for a compile. There's some errors.
Like I feel like there was an XKCD that was public for this.
There is one actually. There absolutely is. There's different excuses from different kinds of developers as to what's going on. And let's see if I can manage to get. Oh, look, it finished. There are some warnings because some of the libraries are like doing weird things, and in fact, in order to get this board to work, this is an example program created by SparkFun using all of SparkFun's libraries, and then it won't compile and it won't run. So I downloaded their library, I opened their example program for this board, and I just, without making any changes, tried to run it yesterday, and it was like, nope, won't do that. So now we should be able to deploy this to the board and see it run. And what we'll likely see is we'll see that humidity, that CO2 humidity and pressure line printed twice because I didn't comment out the first version, right? And I added another one. So it's going to verify the boards. It's going to have to go through and make sure that nothing changed in the software, so it doesn't have to recompile. And once things get done, so it's recompiling because it's not actually all that smart. It can't look and say, oh, I just compiled this. I don't have to do it again. So it's going to do it again.
Oh,
And there we go, uploading. And with this board, it's going to do this connecting thing until I hit the button on it to go into boot mode. And now it's writing data and it's hard resetting. And open the serial port. And it's going to give me all this garbage, which I don't know why it does that until I reset the board. Right, and it could not find the PM2.5 sensor because guess what? It can't find it because it's not hooked up. So, so we can go back up here to yeah, see, it's just going to do that. So we'll do this. Come on. We'll comment all that out. And we'll recompile. Now these are short compiles. I have actually had code that would take like, 20 minutes to compile. And I would go away and surf the internet and do stuff, and it's like, well, I really am not just wasting time. I'm waiting for it compiled. Okay.
Yeah.
So what board are you working on?
So I have some questions. Wait. I have some questions. Right. So on Fridays, I work for Cockroach Labs.
Yes.
And every Friday, we effectively have our 20% time because it was founded by Google founders, former Google employees. So
Right.
today's my 20%, which is one of the reasons why I was like, oh, this is cool. I want to learn about IoT. Anyway.
Yep.
But so here's my question, because I'm like at the point where I need to download the Arduino IDE, for example, and deciding whether or not I'm going to put it on my work laptop or my personal laptop. Either one can handle it. But I'm wondering, is there a use case for using a distributed database? Is there a way to use IoT with distributed database with CockroachDB that you know of that I could explore, and therefore it would be I could actually be making something that ended up going into Cockroach Labs.
Yes. So funny story. I actually 3 years ago, interviewed for a job as a DevRel at Cockroach Labs. And I don't know what happened. We just ended up
What?
Yeah.
Okay.
So, but I was my plan for that was going to be doing IoT using Cockroach Labs, CockroachDB.
Yes.
Right? Because one of the things that you always need to do with IoT data is put it somewhere, right? Right now, this is gathering all this data and it's showing me what the data is, but that's not really useful, right? Unless I just want to sit here and scroll this. Oh, look, see, we have our 2 lines, right? Here's the first one, here's the one that we just added, right? So anyway, so yes, putting it in a database is absolutely a use case. And if you are, I guess, distributing your IoT devices, then a distributed database might be a good place to do that. So yes. And in fact, that's something that we can look at doing here on a Friday if you want, of storing stuff into Cockroach Labs.
Yeah.
I typically store data in one of 2 places, just because I worked at both of these places. One is InfluxDB, because it's a time series database and it's easy to store stuff in. And in fact, I wrote the original library to store data from Arduinos into the version 2 of InfluxDB. They've since taken it over and are now maintaining it themselves, since I'm no longer there. And then the other place that I typically store this stuff is in QuestDB, which is another time series database where I also worked for a while. QuestDB is much more of a...
What are you doing for Camunda, if anything?
So that's an interesting question. And in fact, I gave a talk on that earlier this week. I gave a terrible talk on this at a meetup. I guess they didn't think it was terrible, but I did. Anyway, is that where to store the data and how to integrate this with Camunda, because Camunda is a business process management, and so in fact I have, what do you know, I just happen to have Camunda Modeler running here, and I will show it to you because I'm a nice guy. And this is a model actually that I built for the DevRel Collective. We have a thing, we're the benevolent dictators that run it, right? And so there's a dictator bot that keeps track of who's the on-call admin for the week, and so it's called Dictator Bot, and it does all sorts of stuff. But no, that's a daemon. Right. So in this talk, here's a temperature event happens, right? So I'm reading temperature, and a temperature event happens, and I query the database, and is the temperature just right? Is it too low or is it too high? Right? And so what do I do when it's too low? I fire something off to this raise the temperature handler, which deals with whatever it needs to do in the greenhouse to raise the temperature. Same thing for, too high, I go off and do this thing to lower the temperature. And if it's just right, then I do nothing. Okay, good. So that's kind of what I'm planning to do with, how we're going to use Camunda to orchestrate all of this stuff, right? And I've got to build out a whole bunch of these models for handling all this kind of stuff. But these temperature events and other events, how am I going to generate those from all this? And somebody asked in the meetup, well, are you just going to feed all this data straight into Camunda? And it does have a built-in database, and I could do that. But that seems like a rough way to go, with just sort of polluting the Camunda database with stuff that it doesn't care about, right? So one of the options that I was one of the options I was looking at, and I'm going to talk to my colleague Niall about it next week, is the database that underlies Camunda is actually sort of swappable. So I could swap out the underlying database that it uses. It defaults to, I think it's HBase or something. And yeah, it's HBase. And so I could swap out HBase for, I couldn't do it for InfluxDB because InfluxDB is a completely different beast, but I could do it for QuestDB, which is basically a SQL database, right?
Okay, cool.
So then I could do this and store it all in QuestDB and have everything run, everything run on Camunda. The other option is to do something like store the database in an external, either QuestDB or InfluxDB, and generate events from there that start processes here in Camunda. Does that make sense? So that's
right. That makes sense. Yeah.
And the whole thing is, this is a proof of concept, right? So it's kind of figuring out which way makes sense. Part of the whole investigation here is what makes more sense. And maybe, Cockroach makes sense, and we can look at doing it, together and storing everything in CockroachDB. And in fact, hold on, let me look at something real quick. Because, aha, oh, look. Oh, you probably can't read that because it's really small. But Niall sent me.
Are you pulling up CockroachDB?
Well,
no, it's tiny. What are you looking at?
Let's see if the plus works on that.
That evil laugh. We need to talk about this evil laugh.
So, can you see that a little better? So yesterday I was talking to Niall briefly about this. He's my cohort, and he knows way more about Camunda than anybody else I know. And he sent me, I was like, well, I want to see about like swapping out the underlying database for QuestDB. And he's like, well, if it can run one of these ingestion scripts, then it'll work, because these are the create DB scripts that work for the embedded database in Camunda. And the first one on the list is CockroachDB. So we can run CockroachDB, DB2, H2, Maria.
Shut up.
MS SQL, MySQL, Oracle, or Postgres. So I think it's probably possible if we want to swap it out.
That makes perfect sense, because CockroachDB is similar to Postgres.
Right, and it turns out that QuestDB is also wire compatible with Postgres. So it just depends on if it's 100% on the create script. So, but anyway, that's a whole different thing. But we could totally do this in Cockroach. It looks like.
This is so cool.
Because we can swap out.
There's a couple of different things that are coming together for me. One is the OfferZen, the plant detection auto watering thing.
Yep.
And then there's this other project. I think it's done through Arduino. I don't know if it's Arduino or Raspberry Pi, but this project that's about growing things. And I'll introduce you so you can get hooked up as well. And then to also have the database interaction. And then how do we make it global? That's the part, I guess, to put it all in a website that has webcams on all of the growing things.
Yeah. We could do that.
International. That way it's a global database. Yes. Okay.
So one of the things that triggered this whole project for me, I will see if I can find it. Let's show the tab overview. Oh my God, this is going to give everybody a headache. Don't panic, it's okay. These are all my open tabs. These are all my open tabs.
That's awesome.
That's
awesome.
Just.
That's not even bad. I've seen worse.
This is just in one window.
Wait, it scrolls. Never mind.
What's that?
Never mind.
Yeah, it scrolls.
Yeah.
Yeah.
Never mind.
No,
you're good.
Hold on. Yeah, I know it's bad. It's bad. It gives me a headache. It makes me want to just declare tab bankruptcy at some point. Um, but I haven't yet. It may be actually a tab on my other laptop. Um, yeah, it looks like it is. Look, I wrote a blog. I wrote a blog, and you're in it. See,
Hey, I'm totally gonna
you're on.
retweet that.
You're on
That's
the.
cool.
You're on the header image for it.
I know that person.
Yeah. So anyway, I was reading a bunch of stuff about um, building management. The sort of the smart building stuff, which is huge and growing, right? And one of the subsets of that is
Right.
actually greenhouse management. Greenhouse management is big business, and because of the legalization of marijuana in many states in the U.S., greenhouse automation, because all of that has to be done indoors. It is illegal in
Like-
every single state to grow it outdoors. So it all has to be done indoors. And those greenhouses have to be
Right.
very, very, very well controlled, or things just don't work. You grow bad weed, and nobody wants to grow bad weed. And so it's actually
I
huge
think that's
business.
the same here in the Netherlands, by the way.
Yeah, that wouldn't surprise me.
The crops are not outside.
Yeah, they can't be, because then people could just wander in the field, and they'd be outstanding in your field.
Yeah. They would be outstanding in their field.
Yes. So anyway, that was the whole genesis of this project, of why I'm doing this project, right? And in fact, if we go and look at, I wrote a blog post about that too. Here it is. And here's the growth in just IoT, right? It goes from, we're in 2021, $418 billion up to $1.5 trillion in 2025. And here's my sort of my greenhouse, right, of how we're going to do all this. And they're saying analytics and machine learning, which we could also add, right? But just doing equipment control and remote management with Camunda is probably enough. The global smart greenhouse market was valued at
I have
just under $1 billion in
analytics
2000.
and machine learning person in Microsoft.
Really? Outstanding.
That could be a collaborator.
That'd be cool.
Yeah.
So U.S. greenhouse market was just under $1 billion in 2018. It's going to be almost 2.5 billion by 2026. That's huge growth. There's huge potential there for what you can do with this stuff, right? And yes, cameras are also going to be part of it. Cameras should also be part of it, because you want to monitor your greenhouse, and you want to see what's going on, and see what things. You can't, I guess, 100% rely on just what the sensors are saying, right? Eyeballs are still good things. So having eyeballs on it is still a good thing.
There's a certain level of security and whatnot, especially with marijuana.
Yep. So that's
But even for like medical, well, I guess marijuana is technically a medical crop, but for other medical crops.
Yeah. Well, and it's really for any controlled crop. And one of the things that we were talking about is, in why you would use Camunda was, okay, well, as the sort of the business manager, I know all of this stuff, right? And depending on the crop, right? So here's the decision of what's too low. If the temp is below 35, that's too low, right? But as the overall sort of greenhouse manager, I'm the one putting the crops in there. I know for that crop, I know what the temperature should be, right? What the temperature range should be. It should be between 35 and 50 degrees. Well, we're talking Celsius, that's really hot, but still. Um, so whatever we're growing, but as the business manager, I need to know these things. I don't want to have to go into the code and change that, right? So all I want to do is go in here and say, no, 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 no. This crop uh, too low is 20 degrees, and too high is anything over 32 degrees, right? And now I don't care, right?
You're not a developer.
Right, I'm not a developer. I don't want to know. I don't want to have to go rewrite the code that adjusts the temperature for higher or lower. I just want to be able to set the temperature thresholds. I just did that. I just changed crops, right?
Yeah.
And now I changed crops, and the greenhouse takes care of making sure that too high and too low are handled. And as the greenhouse manager, I just changed crops, and that's all I had to do was go change those little things.
Well, I can't build anything too big yet. I will know in the next few weeks whether or not I can. And in the meantime, there's a lot of setup that can happen on my side.
Yeah.
So, yeah, I'll see you next Friday, hey?
Yeah, and I think we should definitely look into swapping out the Camunda database with Cockroach and storing all the data in Cockroach. I need to look into swapping it out with QuestDB as well, just for my own, side of the project. But I think this has potential for being a great sort of longer term collaboration, right? And making this all work.
Yeah.
That makes me very happy.
Cool. Yay!
Yay! Okay.
Yes, me too.
Well, I'm glad you.
And now I'm going to do the maker's prep on my work laptop.
Well, at least we got to help you make a decision then, right?
Instead of my personal. Yeah, thank you.
Well, and maybe next week we can do a little bit more with getting your setup going and all of that. How's that sound?
Okay, sounds good. Yep.
Okay. Well, let's sign off of the streaming here and say goodbye to our fan or whatever. I don't think there's anybody watching, but that's okay.